Hi, this is Mark Malberg with Digital Metrology, and today we're going to take a quick look at OmniSurf3D's pit and porosity analysis. So as always, I'm going to clear out the settings so we can see everything happening within the video. Nothing has been set up to make this easy. It's just going to be interaction. So let's drag in a data set and interact with it a bit. Now this data set was already leveled, so there's nothing more I need to do with it. We can see that there are some interesting pores. There's a bit of a scratch running through the data. So let's go straight to the pit and porosity analysis off the tools menu, and we see that we have an interactive tool for slicing through the surface. Now one of the underlying concepts in OmniSurf3D is to make everything visual. So anything that you do with the data that produces a number should have some kind of image to support it. And that's the way our brains and eyes were designed as we interact with surfaces regularly. So our mathematical analysis should have some visual basis as well to make it the most informative. So you can see as I slide this slice level up and down through the material ratio curve, I also see a transparent cutting plane slicing through the surface and showing me which features are being sliced at that particular level. Now, along with the visuals of this tool, we see a plot over here on the right where the red areas indicate closed pores. A closed pore is anything that we can see the entire perimeter of. As I work my way up, we see some turn blue. A blue feature is what's called an open pore. Open means it's open to the outside world off the edges of the data set. For example, if we measured an entire surface, open pores would leak off the edges. Another interesting feature that is quite visual inside OmniSurf3D's porosity analysis is as I slide this level up, we reach a point where my open pores actually connect, and the visual here is quite helpful. It turns green, and this is an edge connected area. In other words, it's a leak path across the Y direction of the surface. Now we have numbers to support all of these things we're seeing graphically. For example, at this depth, there are 746 pits. 42 are open and 704 are closed. Or we can calculate a pit density. How many pits per square centimeter? This is a much more useful way of looking at a number of pits, because sometimes we might want to zoom in on a small area of the surface and our total number will change even within the same surface. So it's more useful to use something like a density, which doesn't care about how much measurement area. Now, on the open and closed analysis, over here, this plot shows us the number of closed versus open versus connected features. In this world, we talk about area. For example, 27% of the surface is made up of pores at this slice level, at this cutting plane, or at a slice depth, which is currently negative 39 micrometers. So we have 27% of the surface made up of porosity. 2.7% of that surface is actually connected. So this is the area of the surface that would be a leak path along the y-axis. It's a y-connected pit area. Now this tool for interacting is quite powerful. We can look around and determine some level that makes sense to us. For example, I'm at negative 51 micrometers as I slid the cutting plane there, and that might be a nice level for specifying and comparing. However, it would be a real challenge to compare between surfaces using the cursors because we don't always land in exactly the same place. So OmniSurf3D gives us a language for doing this. We can actually manually choose a height. So a height would be a positive number above 0. Let's make it a depth by giving it a negative number. For example, negative 50 micrometers. If we apply this, the cutting plane will move to that level, the material ratio curve will move to that level, and the plot will update for the 50 micrometer level. And sure enough, we've now set it exactly 50 micrometers, and we can do an analysis, and we can even export these numbers for this surface and compare it to other surfaces. Height above a mean line is useful. In some cases, we might want to use a standard material ratio reference. So we can come down to a 5% reference level, the SMR 0 value we talk about in standards. So from that 5% reference, somewhere around here would be the 5% reference. And we're going to drop some depth. So I'll zero this and then come down some amount, say 150 micrometers below the 5 micron depth would put us here. So 5 microns, 150 microns down, we can apply that, and that becomes this point on the curve, this slice level, and these numbers apply. So it's a useful way of choosing a specific level so we can compare surfaces. And as always, OmniSurf3D makes things very visual, so we can actually see in the surface, in the analysis, what we are actually trying to describe with the numbers. As always, if you have any questions, hit digitalmetrology.com, shoot us an email via the contact link, and we look forward to talking to you. Thanks.